been cutting, so I just forgot. So we have something called electromagnetic spectrum. Electromagnetic spectrum. Now, when we say spectrum, we are talking about varieties of what they call it. In this case, we are talking about varieties of waves with different wavelengths. Varieties of wave with different wavelengths and frequency. Varieties of wave with different wavelengths and frequency. We call them electromagnetic spectrum. And so we are saying that electromagnetic spectrum is a classification of electromagnetic waves according to their frequency or wavelength. So electromagnetic wave spectrum is a classification of electromagnetic waves according to their frequency or wavelength. I hope you get it. Hmm?
Yes, sir.
Yeah. Now we have the spectrum consists of this is what the spectrum consists of, and I said that each of them have different frequency and wave wavelength. So the arrangements are normally based on their frequencies and their wavelength. Now the spectrum consists of gamma rays, X-rays, all these you've heard of it before, visible light, infrared, and radio waves. They consist of X rays, gamma rays, X rays, visible light, infrared, and radio waves. Radio waves. Radio waves. Sister small.
Sir.
Yes. So I said that the spectrum consists of gamma rays, X rays, visible light, infrared, and radio waves. Now, let me just, and I said they are arranged according to what they are called their increasing wavelength and increasing frequencies. And so, for instance, let me just draw a normal box. Draw it well. This is just a free sketch. We have S ray coming first. We have S ray, and normally we have S rays, and so check the spelling well. S rays, and in the same box we have something called we have the gamma rays. Gamma rays. This is gamma rays. The symbol is gamma, so gamma rays. You know how you write this gamma symbol? Gamma rays. And from there we have the ultraviolet rays. Ultra, ultra, ultraviolet. Then after the ultraviolet, we have the visible. You have the visible. So the whole of this part we call it visible. That's from here to here. It's visible. And after the visible, we have the infrared. 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 Those are before Bluetooth. This is what we are using for connection. And after that, we have what we call the radio waves. And in the radio waves is where we have the microwaves. The microwaves. So we have them radio waves. Radio waves. Radio waves. And in the same that radio waves is where we have the microwaves, the TV, the sound waves, the radar, broadcasting, and the rest. The waves that what they call they use for the TV broadcast and the rest is in the same radio waves and microwaves is where we have that waves, and they are not normally not visible. They can only be seen with a spectrometer. You can have the TV waves and the. I hope you know what a radar is. The sound radar and the rest. I hope you know what a radar is.
Say no.
Oh, you realize that when you're in a car, before you get to the barrier, the police they've been holding a certain gun. They call it speed gun. They use it to check the speed. Have you seen that this? They point it to your car, then they detect the speed. So immediately you get it, they thought, okay, maybe whether you are driving at what they call it, at a higher speed or something. Have you seen that gun the police people have been holding? They point it at your distance. Have you seen it? That's what we call the radar. When we get to there, I'll explain it. The name itself is the radar is RADAR, and the R stands for radio. RA stands for the radio. The D stands for direction, and direction. The A stands for end. Then the other R stands for ranging. So when you get to the, I'll just give you a brief explanation of it. So that is it. And this is increasing what they call it wavelength. This is increasing wavelength. Increasing wavelength. Increasing wavelength. When we get to atomic energy, we explain it more better. Increasing wavelength. This is wavelength. Wavelength. You can add it. Then this side is also increasing frequency. Increasing frequency. Increasing frequency. Increasing frequency. So it means that the X-rays have shorter wavelength. Looking at this. And so the X-rays and the gamma rays and the ultraviolet, this one has a shorter wavelength compared to the ultraviolet waves, also compared to that of the visible spectrum, and also compared to that of the infrared. So it increases. And so this is bigger than this. This has a wavelength more than this. This has a more wavelength than this, and so on and so forth till it gets here. So realize that the radio wave have the highest wavelength. However, it has also the smallest frequency because it is also increasing. And so here the gamma rays and the X rays will also have a higher frequency. That's what it means. And so that is so the gamma rays down to 1 million of the wavelength of light. And the visible spectrum have an average wavelength 0.00005 millimeters. The radio wavelength range from 1 millimeters to 10 kilometers. So that is it. That is it. So there's a diagram to just represent it. We are also going to discuss them briefly. When you're done drawing, we'll discuss them briefly, then we continue.
So I'm done drawing.
Okay, so now let's talk about the production and use of these electromagnetic waves. Let's first talk about the gamma rays. The gamma rays. Normally, the gamma rays are normally gotten from the nucleus, the radioactivity of the nucleus. And so normally we use them in the nuclear physics. The disintegration of the nucleus. Some of the energies that come out is what we call the gamma rays and the alpha and beta particles and the rest. So that is it. So the gamma rays, they are normally produced as a result of energy changes within the nucleus of an atom, just as I said. And they are normally used for sterilization. They are used for sterilization. I hope when we say sterilization, you know, they are used for sterilization. sterilization, like cleansing. So when you go to the hospital, some of the instrument they use, after they use the instrument, because they are instrument that a lot of people will be using, after they use the instrument, they put it in the sterilizer to just sterilize it or take away any particles that what do you call it, that is on any harmful particles or microbes that is on the instrument, so that they can make the instrument fresh again. And so we use, with the help, we use gamma rays to do those sterilization. Do you get it? Even when you go to even a barbering salon, you realize that they have the sterilizer that after
Yes, sir.
they finish shaving you, they put it into the sterilizer for a certain time, so that anytime another person comes, it would have been sterilized. If not, you would have been getting what do you call it, a lot of sickness from the barbering salon and so on and so forth. Have you noticed that? So that is it. So the gamma rays is used for sterilization. Now let's look at the X-rays. The X-rays is normally produced by firing electrons at a metallic target. And so when electrons are fired at an metallic target, that is where we produce the X-rays. And they are normally used for forming images of bones in the body. So you realize that if you have an accident or so on and so forth, normally they use the X-rays to, what do you call it, to be able to get the images of the bones in your body. That tells them or gives them a picture of what do you call it, the extent to which your bones are damaged, or the extent to which your bone is damaged, especially when you have an accident or when you have a fracture or anything. And so you realize that anytime you have a fracture, they tell you to go for a scan. And so it's a machine that is able to tell us, it gives us a picture or an image of how the bone is and so on and so forth. And so that is it. So that X-ray is what we use in doing all those, and it is normally used for also in other jurisdictions. It's also used for treatment of diseases. It's also used for treatment of disease and so on and so forth. And it's very powerful. So they if you are not a specialist, you can't be able to use it. You can't be able to use it. That is it. Now let's look out for the ultraviolet rays. The ultraviolet rays. Let's look out for the ultraviolet rays. The ultraviolet rays. Ultraviolet, visible, and the infrared. We are talking about all of them in bulk. Like ultraviolet, visible, and infrared. They are normally produced when electrons change their energy levels. So when electrons change their energy levels from one level to another, when you get to atomic physics, when I explain all these things, they are produced when electrons change their energy levels within atoms. Within atoms, the ultraviolet is used for brightening of dyes. So within atoms, ultraviolet are normally used for brightening of dyes and paint. So because the ultraviolet is able to change color, that's why it's called ultraviolet. And so within atoms, it is normally used in brightening of dyes and also used in paint. It's also used in paint because it can change the color of the paint. And so that's what we use the ultraviolet for, rays for. Now, the visible light is for illumination. It is for illumination. The visible distance is for illumination. The visible light is for illumination. The visible light is for illumination. So when we talk about illumination, the light that comes into our room and so on and so forth is the visible light. So it is used for illumination. That's without the light we can't see in the night. So that's what basically is used for. Illumination is what it means. So the visible light, it makes us to be able to see. It makes this thing visible. That is all. And the infrared is normally used for warming and heating. So the infrared is also used for warming and heating, and it is normally obtained from the sun. So the infrared is normally used for warming and heating, and it is normally obtained from the sun. It is normally obtained from the sun. It is normally obtained from the sun. Now let's talk about the last one, which you call the radio waves. The last one, which you call the radio waves. The radio waves are normally produced by oscillation of electrons in an area. When I say area, in the air, or in vacuum, in the air, let me put it that way. An area. Sorry, I'm coming. An area. So they are produced by oscillation of electrons in an area, and they are normally used for transmitting information. So they are normally, when you say area, they are performing in the air. So you realize that the radio waves they are performing in the air. Oh. The radio waves you've been using, they are performing. They what do you call it? They work in the air, so you can't see them. So that is, they are using transmitting of information and so on and so forth. And so that's basically what we use. It's the same waves that we use in our making our calls and so on and so forth. They are all distant radio waves. They are all radio waves. So it's normally produced. They are normally produced by oscillation of electrons in the air, and they are used for transmitting informations. And that is all. So our phone, when you call, sometimes have you one day wondered how when you call somebody, the person from another place can be able to pick, and you're able to talk and so on and so forth. Yeah, all as a result of these radio waves. They move in air. So that is it. Now let's talk about one or two properties. We have just less time. Let's talk about one or two properties of electromagnetic waves. Electromagnetic waves, like all waves, they are waves, so they perform all the properties associated with waves. That it has to do with, they can be reflected, they can be refracted, they can be interfered, and they can also be diffracted. So they undergo reflection, refraction, interference, and diffraction. So that is it. The rest is reading. That is it. And we have what we call the radar. Let me just explain what the radar is. The radar is what I told you. You realize that when you're in a car, the police want to stop you and they are not stopping or something. Or before, anytime your mom is driving or anytime someone is driving, you realize that before they get to the tobu or where the police is, they normally slow their car down because they don't want, the police have machines that they use to detect the speed at which you were driving. So if you go beyond, or if you went beyond what they call a threshold, the speed threshold. When I say speed threshold, I know in every, what they call it, when you are driving in town, especially in Accra and so on and so, because there are a lot of movements, you are not supposed to go above a certain threshold because there are a lot of movements of human beings or passengers. So if you go beyond that threshold, or pedestrians, so if you go beyond that threshold, you might end up knocking someone. So it's the responsibility of the police to check that drivers don't go beyond that threshold. As I think it's about 50 kilometers per second or something, or 50 meter per second. That is the speed you are not supposed to go. So if you go beyond that, then that means because they believe that if you are driving at 50 and mistakenly someone crosses you, because the speed is not that high, you can be able to at least brake. And if you even hit the person, it wouldn't affect the person than if you were going above that threshold. If you are driving above, like 100 and so on and so, that one you can just use that when you're going for long journeys where people, we don't assume people will be moving and stuff, like going to the outskirts of the country and so on and so forth. That's where you can be driving at maybe that high speed, but normally in town where people are moving, listen. So the scientists came up with this machine which we call the radar, and the radar stands for radio direction and ranging. And normally it consists of a source given out electromagnetic waves and receiving waves reflected by the object hit by the waves. And so what they do is, it's,
Spell
is that I should spell the radar. The radar is radar.
Solsting.
You said,
The Solsting.
I said it consists of a source giving out electromagnetic waves and receiving the waves reflected by the objects hit by the waves. It consists of a source. It consists of a source giving out electromagnetic waves. It consists of a source giving out electromagnetic waves. It consists of a source giving out electromagnetic waves. Consists of a source giving out electromagnetic waves and receiving the waves reflected by objects hit by the waves. And consists of a source giving out electromagnetic waves and receiving the waves reflected by the objects hit by the waves, by the object hit by the waves. So normally it consists of a source that gives out electromagnetic waves, and when it gives out the electromagnetic waves, it receives waves that are reflected by the object. So in this case, it receives waves that are reflected by the car. You get it? That are reflected by the car. And the reflected waves are used to locate the position of the object. So the reflected waves are used to, that means the wave that's when you realize that when the radar hits the car, it's the waves reflect back. That is one of the properties of this thing. So that reflected waves normally locates or shows the position of the object using the speed of the electromagnetic waves and the time between the emission of the radiation and the reception of the reflection. So the time it hits it and the time it returns, it calculates using its speed and so on and so forth. And it is able to determine the speed of the car. You get it? And the source and the detector of the radar equipment may be rotating, in which case it is used to scan an area such as scanner and so on and so forth. So basically, that is what it uses. So the main principle behind it, it uses what we call the reflection. It uses what we call the reflection, and it's able to calculate the speed. That means taking into consideration the time, the what do you call it, the waves traveled to hit the object, and the time the reflection also took place, and so on and so forth. And it's able to determine the speed and the rest. When we talk about this thing and the distance and the rest. So basically, that is it. That is the little and the normal waves we are going to talk about. So, under waves, we spoke about stationary waves, progressive waves, how to calculate for progressive wave, rare functions, what do we call it, crest and troughs, progressive waves, transverse waves, longitudinal waves, amplitude, and so on and so forth. The next time we meet, we are going to talk about sound waves, where we'll be looking at the propagation of sound waves, the velocity of sound wave. You also be looking at noise and difference between noise, notes, characteristics of the sound wave, the pitch, loudness and intensity. We also be looking at echoes, calculation of echoes. We'll be looking at Doppler effects, characteristics of sounds, vibration in pipes. I think that will be the last topic, and we are done. So by the end of the month, we are supposed to finish with waves. The next month, God willing, if we have strength, we also, and everything moves on smoothly, we also pick one topic and also finish it up. Then you can prepare for school. I hope I made myself clear.
Sir, yes, sir, please upload the video on YouTube.
I hear.